Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 3 video on the chapter of factorization, where I will solve the objective questions from the exercise 7E given in the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos for the first time and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the exercise 7E, which are MCQs on the chapter of factorization. Okay, so I have the exercise 7E problems on the left hand side, and on the right hand side I will solve the problems. I hope you can see the questions from the exercise 7E, and it is the fonts are big enough so that you can read it properly. Okay, there are a total of 20 questions, so ideally you should not take more than 40 minutes to solve all these problems. Okay, let's start solving the problems. The first one is 7a square. It is given that we have 7a square minus 63b square. It is asking what will be its factorization, because all the choices are we can see all the choices are product of some factors. So we have to basically factorize this polynomial. So okay, now 7a square, a square is fine, but 7 is not a perfect square, and 63 is also not a perfect square. But if you take common 7 from both the terms, I get 7 multiplied by a square minus 9b square. Now I can see a square minus 9b square is in the form of a square minus b square, and hence we can factorize. We know that a square is a square and 9b square is 3b square of 3b. So now I have the form a square minus b square, and I can factorize it as a minus 3b multiplied by a plus 3b. So this is the factorization of the given polynomial, and this is the factorization of the given polynomial. So the correct choice is D. D is the correct choice. So while I am solving the problem, you can pause the video and take screenshot if you think it will help you. Problem number 2. So all these are basically some polynomial equals to question mark. By question mark it means we have to find the factorization. Okay, so the polynomial is 2x minus 32x cube, and we can see that it is a difference of two terms, that is 2x minus 32x cube, and none of the terms are squares. That is 2x is not a square and 32x cube is not a square, but we can see we see there is a common factor of 2x from both the terms. So whenever you have a polynomial and you see that all the terms are having a common factor, it is a standard method, standard strategy to factor out that common factor from all the terms. So I can see the common factor of both the terms, that is 2x and minus 32x cube, is 2x. See, if I factor out 2x from both the terms, I get 2x multiplied by 1 minus 16x square. Now I see I have to factorize 1 minus 16 square, which is of the form a square minus b square, because 1 is 1 square and 16x square is square of 4x. So now this will be the final factorization will be applying the identity a square minus b square equals to a minus b into a plus b. We get 1 minus 4x multiplied by 1 plus 4x. So this is the factorization of the given polynomial. So the answer will be D. Answer is D. Okay, let's do the third problem. Let's utilize the space. Third one is x cubed minus 144x. Now clearly I can see x will be a common factor from both the terms. X will be a common factor from both the terms. So let's factor out x, and we get x multiplied by x square minus 144. Now we have to factorize x square minus 144. And we know that 144 is 12 square. So we got the a square minus b square form where a is x and b is 12. So the factorization will be x minus 12 multiplied by x plus 12. So this is the final factorization. And the answer must be the correct choice is C. C is the correct choice. Okay, let's do problem number 4. It is 2 minus 50x square. Now 50x square, 50 is not a perfect square, also 2 is not a perfect square, but we can see that we can factor out 2 from both the terms. If I factor out 2 from both the terms, I get 2 multiplied by 1 minus 25x square, and hence we have to factorize 1 minus 25x square because it can be expressed as a square minus b square, that is 1 square minus square of 5x. And so the final factorization will be 2 multiplied by 1 minus 5x plus multiplied by 1 plus 5x. This is the final factorization. So the correct choice will be D. Correct choice is D. Correct choice is D. Okay. Let's do problem number 5. Okay. Problem number 5 is a square. The polynomial is a square plus bc plus ab plus ac. Now clearly we can see that it is not of the form a square minus b square, neither it is of the form a square plus b square plus twice ab or a square plus b square plus minus twice ab. But we can see that, and also there is no common factor in all the terms of the polynomial. So the option we can apply is grouping. We have to group terms so that each group will have a common factor. And so if you form two groups, the first group being a square plus ab, and the second group being having the terms bc and ac. Now you can factor out. So this is group 1. We have just formed two groups. So this is factorization by forming groups. So if I can factor out a from the first group, and I get a multiplied by a plus b. And I can also see I can factor out c from the second group, and it becomes c multiplied by b plus a. Now I can see that both the groups are having a common factor of a plus b, and hence the final factorization will be a plus b multiplied by a plus c. So this is the final factorization, and hence the correct choice is choice A. A is the correct choice. Okay, let's do problem number 6. The polynomial is p q square plus q into p minus 1 and minus 1. Now clearly we see that there is no common factor in all the terms. Also it is not of the form a square plus b square, a plus b whole square, or a minus b whole square. Neither it is of the form quadratic trinomial. So the only option we can apply is we have to form some groups so that each group will have a common factor. Okay. So let's simplify. Let's expand the product of q into p minus 1. So we get p q square plus qp minus q, and then we have minus 1. Now, what will be the groups? You can form the groups as the first two terms, taking the first two terms as the first group, and the second terms, the third and fourth term, the last two terms forms the second group. So this is group 1 and this is group 2. Now I can see that I can factor out QP. QP is a common factor from the terms in the group 1. So if I factor out PQ from the first group, I get PQ multiplied by Q plus 1. And also there is no common factor in the terms of the second group. But if I take minus 1 common from this from all the terms in the second group, I get this will be minus of 1 plus q or q plus 1. Now I can see that both the groups are having a common factor of 1 plus q. So the final factorization will be 1 plus q multiplied by pq minus 1. So this is the final factorization. 1 plus q multiplied by pq minus 1. So the correct choice is D. The correct choice is D. Correct choice is D. Okay. Let's do problem number 7. Problem number 7 is AB, the polynomial is AB minus MN plus AN minus BM. Now clearly we can clearly see that we have to apply the grouping of terms, because we don't see any square, that is it is not of the form a square minus b square, or it is of the form a plus b whole square or a minus b whole square, nor it is of the form quadratic trinomial. So based on the concepts what we have learned discussed in the previous videos, we can only apply the concept of grouping, that is we have to group terms so that each group will have a common factor. Now, so the grouping could be AB plus AN, and the other the second group will be minus MN minus BM. Remember the terms in these polynomials are AB minus MN plus AN and minus BM. Okay. Now, so this is group 1 and this is group 2. From the group 1, I can take out A as the common factor from all the terms of group 1, and I get A multiplied by B plus N. And from the, let's rewrite the second group. Let's take minus 1 as common factor from all the terms in group 2, and we get Mn plus Bm. So this is equal to A multiplied by B plus N minus, now I will take M as common factor from all the terms of the group 2. So we get M multiplied by N plus B. So now we can see that B plus N is the common factor of both the groups. So the final factorization will be B plus N multiplied by A minus M. So this is the final factorization. B plus N multiplied by A minus M. So the correct choice is B. The correct choice is B. Okay. Let's do problem number 8. AB minus A minus B plus 1. So clearly we will form groups, two groups. The first groups will be the first two terms, and the second groups will be the last two terms. So this is equal to, let's say, AB minus A, and the second group is minus B plus 1. So this is group 1 and this is group 2. Now I will factor out, I will take A as common factor from all the terms of group 1, and I have A into B minus 1, and from the group 2 I will take minus 1 as common factor from all the terms, and it becomes minus of B minus 1. Now I can see both the group are having B minus 1 as the common factor, and so the final factorization will be B minus 1 multiplied by A minus 1. So this is the final factorization, and hence the correct choice is A. A is the correct choice. Okay, let's do problem number 9. Okay, problem number 9 is x square minus xz plus xy minus yz. Now this is also, even though you can see the term x square, it is not a quadratic trinomial. It is, well, is it a quadratic trinomial? Let me see. Okay, so this is x square, and you see there are two terms, minus xz and plus xy, from where you can take x as common. So if I take common x from the second term and the third term, I get plus x multiplied by minus z plus y. Okay, and we have minus yz. Now the thing is that now you must be familiar with one formula or identity, that x, a quadratic trinomial of the form x square plus a plus b multiplied by x plus ab can be factorized as x plus a multiplied by x plus b. This is very important, you must always remember. So in this given polynomial, which is also a quadratic trinomial, we can see it is x square plus x into minus z plus y. It is not of the form y plus z. Also the last term, it is minus yz, it is not plus yz. So this form is not exactly equal to the form on the right hand side, that is x square plus a plus b into x plus ab. If it was exactly of this form, we could have factorized the given polynomial as x plus a into x plus b. So this concept, the identity on the right hand side will not apply to this given problem. So anyway, I was trying to see if that works or not. So anyway, we have to do grouping. So if you group, so the polynomial is x square minus xz. Now there are some in problems you have to visually understand how you should do grouping. If you form groups like this, the first two terms is the group 1 and the last two terms is the group 2, then you can clearly see that from the first group x can be factored out, and it will be, if I take x common factor from the group 1, it will be x multiplied by x minus z. And also from the group 2, if I take y as common factor, it will be y multiplied by x minus z, and we can clearly see now that both the groups are having a common factor of x minus z. So the final factorization will be x minus z multiplied by x plus y. Always remember that when you are applying the forming groups, factorization by forming groups, whatever groups you form, it can be 2 groups, 3 groups, or 4 groups. All the groups must have a common factor. Then only you can do the factorization. So this is the final factorization of the given polynomial, and hence the correct choice will be x minus z, x plus y. So it is correct choice is C. C is the correct choice. Okay, let's do problem number 10. The polynomial given is 12 m square minus 27. Now clearly we can see that 27, it is of the form a difference of two terms, but the terms, both the terms are not perfect square of something. 27 is not a perfect square. 12 m square, even though we have m square, but 12 is not a perfect square. So you can see that we have to take some common factor. Now between 12 and 27, the HCF of 12 and 27 is 3. So you have to factor out 3 from both the terms, and we will get 4m square minus 9. Now we can see that we can factorize easily 4m square minus 9 by minus 9, because it is of the form a square minus b square, where a is twice m and b is 3. So now applying the identity of a square minus b square, we can say it is 3 multiplied by 2m minus 3 multiplied by 2m plus 3. This is the final factorization, and hence the correct choice is 2m minus 3, and the correct choice is C. C is the correct choice. Okay, let's do problem number 11. X cube minus x. Now clearly it is not of the form a square minus b square, but we can clearly see that all the terms are having a common factor of x. So whenever you have a polynomial and you see all the terms are having some common factor, it is better to factor out that common factor and then factorize the remaining term. So we have, if we factor out x as common factor from both the terms, we get x multiplied by x square minus 1. And we know that we can factorize x square minus 1 as x minus 1 multiplied by x plus 1. So this is the final factorization, and hence the correct choice is, remember the correct choice is not C, the correct choice is D. C, it is 1 minus x, but actually the factor is x minus 1. So it will be D. Let's do 12. The polynomial given is 1 minus twice AB minus of a square plus b square. Okay. Now, okay. So we see the term a square, b square, and also twice ab. Let's see if we can somehow arrange them properly to get either a minus b whole square or a plus b whole square. So this is 1. If I put, first of all, let's open the bracket and we get minus a square minus b square. Now if I put the terms minus a square, minus b square, and minus twice ab inside a bracket, I get 1 plus minus twice ab minus a square minus b square. Now if I take minus 1 as common from all the terms of the expression inside the bracket, I get minus 1 can be taken out, and it will be 1 minus twice ab plus a square plus b square. Now we can see that twice AB plus A square plus B square is A plus B whole square. A plus B whole square. Now we clearly see it is of the form A square minus B square, because 1 can be written as 1 square. So it is of the form A square minus B square, and hence the final factorization will be 1 plus A plus B. Actually it will be 1 plus A plus B and a 1 minus A plus B. Now this will be 1 plus A plus B multiplied by 1 minus A minus B. So this is the final factorization, and hence the correct choice will be correct choice is C. C is the correct choice. Okay, let's do problem number 13. The polynomial given is x square plus 6x plus 8. So we can see clearly it is a quadratic trinomial, that is it is a polynomial of 3 terms, and the degree of the polynomial is 2. So we will definitely try to apply the concept of factorization for a quadratic trinomial, that is which is of the form a polynomial of the form x square plus px plus q. We will try to find a and b such that we will try to find the numbers a and b such that a plus b is equal to p and a b is equal to q. If we can find such a and b, then we can say we can factorize this as x plus a multiplied by x plus b. It is important to note that any quadratic trinomial of the form x square plus px plus q, you may not find, for the values of p and q, you may not find a and b. So you cannot factorize it as x plus a plus multiplied by x plus b, because you will not be able to find a and b for the values of p and q. But if you can, then you can factorize like this. So let's see. For this problem, we must have a plus b equal to 6 and ab will be equal to 8. Now what is 8? 8 is equal to 4 into 2, and we can clearly see 4 plus 2 equals to 6. So we can write it as x square multiplied by 6 can be written as 4 plus 2 x, and we have plus 8. So this is equal to x square. If you open the bracket, we get 4x plus 2x plus 8. Now we will form groups. This is the first group, this is the second group, and we will factor out x from the first group, and it becomes x multiplied by x plus 4, and from the second group I will factor out 2, and it will be 2 multiplied by x plus 4. So the final factorization will be, so that we can see that both the groups are having common factor of x plus 4. So the final factorization will be x plus 4 multiplied by x plus 2. But if you are solving this kind of MCQs for any exam or test, then once you have found a and b, you can directly say that the factorization will be x plus a into x plus b. So this is the final factorization, and hence the correct choice will be x plus 4 multiplied by x plus 2. So it is C. Correct choice is C. Okay, let's do problem number 14. Problem number 14 is again a quadratic trinomial, that is x square plus 4x minus 21. So we will try to find a and b such that a plus b is equal to 4 and a b is equal to minus 21. Now minus 21 can be written as 7 multiplied by minus 3, and you can clearly see that 7 plus minus 3 is 4. So directly we can say that if you consider if you consider this as A and minus 3 as B, the factorization directly, you can say it will be x plus A, that is x plus 7 multiplied by x minus 3. So directly you can say you can tell the factors once you have found A and B, such that for this problem A plus B equals to 4 and AB equals to minus 21. So definitely the factorization will be x plus 7 multiplied by x minus 3, and hence the correct choice will be B. Correct choice will be B. But if you want to do the detailed calculation step by step, then it will be x square plus the A plus B, that is A is 7 and B is minus 3. So 7 plus minus 3 into x minus 21. This is equal to x square plus 7x minus 3x minus 21. So you will form group. This is group 1. That is the terms x square plus 7x forms the group 1, and minus 3x minus 21 forms the group 2. You take common x as common from the first group, and you get x multiplied by x plus 7, and you take minus 3 as common from the second group, and you get minus 3 multiplied by x plus 7. So both the groups now are having x plus 7 as a common factor. So the final factorization will be x plus 7 multiplied by x minus 3. Okay, let's do problem number 15. Again, it is a quadratic trinomial, y square plus 2y minus 3. So we have to find A and B such that A plus B is equal to 2 and AB is equal to minus 3. Now minus 3 is equal to 3 multiplied by minus 1, and we know that 3 plus minus 1 is 2. So directly we can say the factorization will be, since A, if we consider A as 3 and B as minus 1, the direct factorization will be y plus 3 multiplied by y minus 1. So this is the factorization, y plus 3 multiplied by y minus 1, and hence the correct choice is y plus 3 into y minus 1. The correct choice is choice A. Okay, let's do problem number 16. For quadratic trinomial, it is all about finding the values A and B such that A plus B equals to P and A into B equals to Q. Once you have found A and B, the job is done. You can clearly say that the factors will be x plus A and x plus B. Okay, so problem 16 is 40 plus 3x minus x square. So it is also a quadratic trinomial. It is that the terms are written in a different order. So let's order it properly. A polynomial is always written, the terms of a polynomial are always written in a way such that they are arranged in descending order of their degree. So we have minus x square plus 3x plus 40. Now remember that this is not of the form x square plus px plus q, because we have minus x square. It is not x square. So what you can do is you can take minus 1 common from all the terms, and it will be minus of x square minus 3x minus 40. Then you can now factorize this part, the algebraic expression, this quadratic trinomial you can factorize, and there will be a minus at the very beginning. Minus 1 will be a factor. You can do this, or you can apply the form of quadratic trinomial, that is px square plus qx plus r, where you can factorize the polynomial of the form px square plus qx plus r, where definitely p is not equals to 1. You have to find a and b such that a plus b is equal to q and ab is equal to pr. AB equals to PR. Let's try to apply this form of quadratic trinomial, that is px square plus qx plus r, because so in this problem we see that p is minus 1, q is 3 and r is 40. So we have to find a and b such that a plus b is q, which in this polynomial is 3, and we must have ab equals to q into r, p into r, where p into r in this polynomial is 40 multiplied by minus 1, that is minus 40. Okay, now minus 40. So we have to find a and b such that a plus b is 33 and a into b is minus 40. Now the factors of 40 can be 10 minus 10 into 4. Now minus 10 into 4, it will not help because minus 10 plus 4 is not 3. How can we create factors? So minus 10, let's keep the minus in the very beginning. So we have a minus 5 into 2 into 4. Now, okay, so how can we create two factors so that their product is AB and their sum is A plus B? I can clearly see that if I take minus 5 multiplied by 8, then 8 plus minus 5 is 3, and of course 8 and minus 5, 8 multiplied by minus 5 is 40. So definitely you can consider this as A and this as B, or you can also consider other way around, that is A is 8 and B equals to minus 5. It will not matter. So directly we can say that the factorization will be x plus A, that is x minus 5, multiplied by x plus B, that is x plus 8. So this is the final factorization we have directly created just by finding the values of A and B, such that A plus B is 3 and A into B is 40 into minus 1, that is minus 40. So the correct choice will be choice B. B is the correct choice. Okay, let's do problem number 17. The polynomial is also again a quadratic trinomial, 2x square plus 5x plus 3. So it is of the form px square plus qx plus r, where p is 2, q is 5 and r is 3. So we have to find the values A and B such that A plus B is equal to q, that is 5, and A multiplied by B will be equal to P into R, that is 6. So we can clearly see that this will be 6 is 2 into 3 and 2 plus 3 is 5. So definitely we can say that the factorization will be x plus 2 multiplied by x plus 3 if you consider this as A and this as B. So x plus 2 multiplied by x plus 3 is the factorization, and hence the correct choice will be x plus 2 and x plus 3. I think I have done something wrong. Oh, sorry. I'm very sorry for this form of quadratic trinomial px square plus qx plus r. Once you have found A and B, the factorization, the final factorization is not equal to x plus A x plus a multiplied by x plus b. No, it is not that. This is true for the quadratic trinomial of the form x square plus px plus q. For this form, you can say once you have found a and b, the factorization will be x plus a into x minus x plus b. But for, no, sorry, not this one. For x square plus px, I'm sorry, for the quadratic trinomial x square plus px plus q, if you can find a and b such that a plus b is equal to p and ab is equal to q, this implies, then you can say that x square, the quadratic polynomial x square plus px plus q can be factorized as x plus a multiplied by x plus b. But this is not true for this is not true for the quadratic trinomial of the form px square plus qx plus r. Once you have found a and b such that a plus b is equal to q and a into b is pr, you cannot say that this polynomial px square plus qx plus r will be equal to x plus a into x plus b. It does not work for the form px square plus qx plus r. So in this problem, it is of the form 2x square plus 5x plus 3 is of the form px square plus qx plus r. So once you have found a and b, you have to proceed like this. So you know that you can write 2x square and 5 you can write as 2 plus 3 and then you have plus 3. So this is equal to 2x square plus 2x plus 3x plus 3. Now you will form groups like this. The first two term will form the group 1 and the second two term will form the group 2, because I know you have to judiciously, wisely form the groups so that both the groups will have a common factor. Because I know that from the first group I can take 2x as a common factor from all the terms, and it will be 2x multiplied by x plus 1. And from the second group I can factor out 3 from all the terms, and it will be 3 multiplied by x plus 1. Now I see that both the groups are having x plus 1 as the common factor, and hence the final factorization will be x plus 1 multiplied by 2x plus 3. So this is the final factorization, and hence the correct choice is B. B is the correct choice. Okay, let's do problem number 18. It is also a quadratic trinomial 6a square minus 13a plus 6, and it is of the form px square plus qx plus r, where p is 6, q is minus 13, and r is 6, and r is 6. So we have to find a and b such that a plus b will be equal to minus 13 and b will be equal to 6 into 6, that is 36. Okay, now we have to find factorize 36 in such a way such that we can take out two factors such that their product is 36 and the sum is minus 13. Now 6 into 6 will not work, because even if we take minus 6 multiplied by minus 6, 6 plus 6 is 12, minus 12. Minus 6 plus minus 6 is minus 12, but we have to find a and b such that a plus b is minus 13. Okay, 13. Okay, now 36 can also be written as 9 into 4, or rather minus 9 into minus 4. And we can see that the sum is minus 13 and the product is also 36. So we can express this as 6a square minus 13. We can 13 we can write it as 9 plus 4. We have a and we have plus 6. So this becomes 6a square and minus 9a minus 4a plus 6. Now you can form the groups. Taking the first two terms forms the group 1 and the second two terms, last two terms forms the group 2, because I know that I can factor out 3a from all the terms of the group 1, and I get 3a multiplied by 2a minus 3. And also from the second group we can rewrite it as, we can put the terms so the second group is basically minus 4a plus 6, minus 4a plus 6. Now if you take a minus 1, if you take plus 2, if you take 2 as common factor from all the terms of the group 2, we get 2 multiplied by minus 2a plus 3, minus 2a plus 3. Now we can see that the two groups are having factors 2a minus 3 and minus 2a plus 3, even though they are same, not same, but we can create the same factor by just let it be 2a minus 3, and from the second group, from the factor 2 minus 2a plus 3, we can take out minus 1 as common factor, and it will be minus 2 of we can say 2a minus 3. Now if this part is unclear, so it was 2 multiplied by minus 2a plus 3. I have to somehow express this in such a way that it will have a factor of 2a minus 3, because the first group is having 2a minus 3, and I know that 2a minus 3 and minus 2a plus 3 are additive inverse of each other. So I just have to take a negative of minus 2a plus 3. If I take a negative of minus 2a plus 3, that is, I take a negative common, it will be 2a minus 3. And this, so if I bring the minus outside, it will be minus 2 multiplied by 2a minus 3, and hence we got this. Okay, so now I see both the groups are having a common factor of 2a minus 3, and so the final factorization will be 2a minus 3 multiplied by 3a minus 2. So this is the final factorization, and hence the correct choice will be 3a minus 2 and 2a minus 3. So the correct choice is C. C is the correct choice. Okay, let's do problem number 19. It is also a quadratic trinomial 4z square minus 8z plus 3, and it is of the form px square plus qx plus r, where p is 4, q is minus 8, and r is 3. So now we have to find a and b such that a plus b is equal to q, that is 3, and ab is equal to p into r, that is 4 into a plus b is not 3, a plus b is minus 8, and ab is equal to 4 into 3, that is 12. So we have to find a and b such that a plus b is minus 8 and ab into 12. Now 4 and 3 will not work, because even if you take minus 4 and minus 3, their sum is minus 7. Now 12 is 6 into 2, which is also equal to minus 6 multiplied by minus 2. Now we can see that minus 6 plus minus 2 is 8, minus 8, and hence minus 6 and minus 2 can be considered as the values a and b. So you can take minus 6 as a and minus 2 as b. It can be other way around also, does not matter. You can consider minus 6 as b and minus 2 as a. So the final factorization, okay, so basically once we have found a and b, we will just express we will just express the q as a plus b. So we have we can write minus 8z as minus 6 plus 2 z plus 3. So this is equal to 4z square minus 6z minus 2z plus 3. Now you can take the first two terms, you can form two groups. The first two terms form the group 1 and the last two terms forms the group 2. So you can form the groups like this: 4z square minus 6z plus minus 2z plus 3. Now you have take out 2z as common factor from all the terms of group 1, and we get 2z z minus 3. And also we can see that we can take so this is 2z from the first group. If I take I can see there is a common factor in both the terms of group 1, which is 2z. So if I factor out 2z, the first group becomes 2z multiplied by 2z minus 3, and the second group is minus 2z plus 3, minus 2z plus 3. Now if I have to express minus 2z plus 3 as 2z minus 3, which are additive inverse of each other. So I can if I take minus 1 common from both the terms of the group 2, I have 2z minus 3, and this minus 1 I can bring outside the bracket, and this will be 2z multiplied by 2z minus 3, a minus of 2z minus 3. Now I can see that both the groups are having a common factor of 2z minus 3, and hence the final factorization will be 2z minus 3 multiplied by 2z minus 1. So this is the final factorization, and hence the correct choice will be 2z minus 3 and 2z minus 1. It is the correct choice is choice A. Okay, let's do the problem number 20, the last problem, which is also again a quadratic trinomial. It is 3 plus 23 minus 8y square. Again, the terms are not in the order. Let's rewrite the polynomial such that the terms are in descending order of degree. So we have minus 8y square plus 23y plus 3. So this is of the form px square plus qx plus r, where p is minus 8, q is 23, and r is 3. So we have to now find the values a and b such that a plus b will be equal to q, that is 23, and a multiplied by b will be equal to p into r, that is minus 3 into minus 8 into 3, that is minus 24. Now how can we find a and b? We know that a plus b equals to 23 and a into b is minus 24. Now this minus 24 can be written as 24 multiplied by minus 1, and now we clearly see that 24 plus minus 1 is 23, and hence we have found a and b. You can consider 24 as a and minus 1 as b, or you can consider 24 as b and minus 1 as a, it does not matter. So now once we have found a, we will just rewrite the given polynomial and replace 23, that is q, with a plus b. So we have minus 8y square plus 23, we will write it as 24 minus 1, and we have y plus 3. This is equal to minus of y square plus 24y minus y plus 3. Now we have to form the groups. We can clearly see that the groups will be the first two terms will form the first group and the last two terms will form the second group. So once we have found the group, we see the groups are minus 8y square plus 24y, and the second group is plus minus y plus 3. Now from the first group, I can see that all the terms, both the terms, there is a common factor of 8y, common factor of 8y. So if I take 8y as a common factor from both the terms of the first group, I get 8y multiplied by minus y plus 3. And also I know the second group is minus y plus 3. So we see that minus y plus 3 is the common factor in both the groups. So the final factorization will be minus y plus 3 multiplied by 8y plus 1. Why 1? Because this group minus y plus 3 is also having a factor of 1. Now this is equal to 8y plus 1 multiplied by 3 minus y. So this is the final factorization, and hence the correct choice will be 3 minus y. It is B. B is the correct choice. So this brings to an end in solving the exercise 7E from the textbook of author RS Aggarwal. This was all MCQ questions based on all the problems where we had to factorize a given polynomial, and I hope this video was beneficial and you understood how this will help you, how you are applying the concept of factorization using the various methods to factorize a given polynomial. That is, how do you factorize a quadratic trinomial of the form of the two form. The first form is x square plus px plus q, and the second form is px square plus qx plus r, and also all the special form of polynomials, that is a square minus b square and a plus b whole square and a minus b whole square. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Now earlier I used to prepare two sample test paper after completing a chapter for where I used to prepare and solve a little harder problems, but I have discontinued making those sample test papers. Instead, I make good problems and solve them in the other playlist, that is Maths 8 HOT. HOT stands for High Order Thinking Problem. So please look out the other playlist, that is Maths 8 HOT, where I will soon prepare and solve 10 good problems on this chapter of factorization. So keep an eye on that playlist for if you want to solve a little harder problems than what we have solved in from the exercise of author of the textbook of author RS Aggarwal. So thanks for watching, and until the next video, take care and bye.